Okay, guys, so here is our last lesson for chapter 10. Okay, and a few things that I want to draw your attention to is that Friday, April 10th, there is no school. It is Good Friday. And Monday, April 13th, there is also no school because it is Easter Monday. So I hope you guys enjoy those days with your family, are still able to watch some Easter services online, and just really reflect and appreciate on everything that Christ sacrificed for us on Easter. And when we come back from Easter, then all we're going to be doing is reviewing and then taking our Chapter 10 test, okay? Our Chapter 10 test is scheduled for April 16th, and we'll be talking more about that as we get a little bit closer. In this last lesson of Chapter 10, we are going to be graphing quadratic inequalities. And so the first thing we're going to be looking at is just defining what an inequality actually is. Okay, so let's take a look at this first slide. And what is the difference between an equation and an inequality? And I know we've been talking about this all year, but it's very important for us to really understand this vocabulary and know how to define it. So an equation has an equal sign, okay? Something like x plus 3 equals 16. There's an equation. An inequality has an inequality symbol. So something like greater than, less than, greater than or equal to, less than or equal to. So the inequality could look exactly the same, but instead of the equal sign, it's going to have an inequality symbol. Okay, so that's the only difference between an equation that has an equal sign and an inequality that has one of these inequality symbols. Now let's talk about quadratic inequalities. Quadratic inequalities have to be two things. They have to be quadratic and they have to be inequalities. Inequalities we just talked about means that it has to have one of our symbols. Greater than, less than, greater than or equal to, less than or equal to. That word quadratic, we've been using it all chapter, and again, very important to know the terminology. Quadratic means that there's an x squared, okay? There cannot be anything else but an x squared. So let's look at some examples. Here, examples 1 and 2. Both of these are quadratic inequalities. Notice they have an x squared, and they also have an inequality symbol. These bottom two are non-examples, okay? The first one has an x squared, but it has an equal sign, okay? And an equal sign is not allowed for a quadratic inequality. It would have to be a symbol. For my second non-example, what's the problem here? It does have an inequality symbol. The problem is that there's an x cubed, okay? And an x cubed would not be allowed in order for it to be quadratic. You can max out only at an x squared. Okay, guys? So now let's talk about whether or not an ordered pair would be a solution. So how can you tell if an ordered pair is a solution to an inequality? Like so much in math, we can plug in, okay? An ordered pair is always in the form x comma y. So plug in that ordered pair and tell me if it's true or not. So let's look at our example here. Tell whether the given ordered pair satisfies the given inequality. So notice my 3 represents x, my -6 is in the y spot, so I'm going to plug in -6 for y and 3 for x. So now what I have is -6 is less than 2 times 3 minus 10. If I keep simplifying this, I get -6 is less than -4 because 6 minus 10 is -4. So this is what now we have to decide. Is this true? Is -6 less than -4? Think of your number line. If we have 0 here, we go -2, -4, -6. So is -6 less than -4? And you would tell me, yes, it is. So the answer to this question, does the ordered pair satisfy the given inequality? Your answer would just be yes, okay? And your first few homework problems are going to be like that, just telling me yes or no. All right, Now let's look at our first method of solving, which is going to be solving on the number line. The second method of solving is going to be solving on a graph. So my steps for solving on a number line: make the inequality equal 0 on one side, factor the other side. Remember, we have our table of factoring. For step 3, solve for each factor. We get 2 answers. For step 4, graph on the number line. Now, open versus closed. If we have the inequalities greater than or less than, then on the number line, we graph an open circle. If we have the inequalities greater than or equal to or less than or equal to, then on the number line, we graph a closed circle. Okay? So just keep that in mind. If there's that extra line underneath, we take the extra step to shade in that circle. And then my last step is to test a point in the middle to see whether we're going to shade in the middle or towards the outsides. So what's going to happen is we're going to get 2 numbers like that, and we need to decide, am I going to shade in the middle or am I going to shade facing out? Okay? And we'll go through the example to hopefully make that make a little bit more sense. So here's our example for graphing on a number line. So solve and graph on a number line. Step 1 is to make the inequality equal to 0. So I already have 0, but I'm going to rewrite it, notice, with an equal sign. Okay? So I don't want to be using the inequality right now. For step 2, I'm going to factor. So how am I going to factor this side? I'm going to work backwards. So I need 2 numbers that are going to add to -2 and that are going to multiply to -15. So my 2 factors are going to end up being x minus 5, x plus 3. So now that I have factored, let's solve for each factor. So I'm going to set each one equal to 0. X minus 5 equals 0. X plus 3 equals 0. So now for solving, I just add 5 to both sides. My first answer is x equals 5. I subtract 3 from both sides. My second answer is x equals -3. Now, step 4 is to graph this on a number line. So I have to draw a number line, okay? So draw your number line here. Make sure, of course, that we include the numbers that are our answers. So I'll start over here at -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and then I'll extend one more to 6. So let's graph those answers. So here at 5, I'm going to put a circle. Now should it be opened or closed? This is where I have to look back at the top at my inequality symbol. If it's greater than, that tells me to use an open circle. Okay, so I leave an open circle here at 5. At -3, I also put an open circle. Now this is where our dilemma takes place. Do I shade in the middle or do I shade going out? So this is where step 5, I test a point in the middle to see where I'm going to shade. Okay, so we can pick any number in between -3 and 5. So I'm going to test a middle number here. An easy number to test is always 0, so I'm just going to go ahead and test 0. Now when I say test, what do I mean? That means I'm going to plug in 0 into the original equation wherever I see x. So let's test that out. And I'm going to test that out here at the top. 0 squared minus 2 times 0 minus 15 is greater than 0. So what I end up with is -15 is greater than 0. Is this true? And the answer is no. -15 is not greater than 0. So that means 0 does not work. So I do not want to shade the middle. So that means I want to shade going to the left and going to the right. Okay? And my graph is my final answer. So I hope that makes sense, guys, this idea of testing out a middle number. If 0 had worked, then I would shade the middle. So let's go to our last piece of this lesson, which is solving with a graph. Okay? And when we're going to graph on a traditional coordinate plane, the first step we have to do is complete the square and write my equation in vertex form. Remember that vertex form looks like this: y equals a, x minus h squared plus k, so that's what vertex form looks like. The second step is to identify the vertex, which is h and k. The third step is to set the equation equal to 0 and solve for x. Remember, when we solve for x, we are finding those zeros. Step 4 is where graphing comes into play. So if we're going to graph the parabola, we want the vertex and the zeros. But then if our inequality symbol is less than or equal to or greater than or equal to, we are going to graph a solid line. So a solid line would look like this. This would be a solid line. If it's just less than or greater than, we graph a dotted line. So here's the difference. A dotted line would look like that. Okay, so be mindful, don't just connect that line right away, because sometimes you may have a dotted line. Then we will have to do some shading. If the inequality symbol is greater than or equal to, we shade up. And if the equality symbol is less than or equal to, we shade down. And again, all the shading always takes place from the vertex. Okay? Now, step 5 is just an option to keep in mind. You can always graph the inequality into your calculator as well to make sure that you're on the right track. Your calculator is not going to shade for you, but you can at least get the parabola and see where you're at. Your calculator is not going to shade for you, but you can at least get the parabola to see if you're on the right track. All right, so let's do our second example here. Graph y is greater than x squared plus 6x. So step 1 is to complete the square and write in vertex form. The first step of completing the square is to put my x terms in parentheses. Then I take b, remember b is the number in front of x, and I do my completing the square rule. 6 divided by 2 squared, which is 3 squared, which is 9. So I'm going to take that 9 and I'm going to add it on the inside. So I'm going to have y is greater than x squared plus 6x, but now I'm going to put plus 9 inside parentheses. And remember to keep balance, if I add 9 inside the parentheses, I have to subtract 9 outside of the parentheses. Now to write this in vertex form, I want to factor this trinomial. Okay, so my x squared plus 6x plus 9, I'm going to work backwards. And what I get are x plus 3, x plus 3 minus 9. So then when I rewrite that in vertex form, y is greater than x plus 3 squared minus 9. So there's my final equation in vertex form. Now, you should all be able to tell me the vertex from here. The vertex comes from hk. Remember, h is the number inside the parentheses. K is the number on the outside. The h, you always use the opposite value. The k stays the same. So my vertex is going to be -3, -9. Okay? Take the opposite of that k and keep the -9 the same. Now, to find the zeros, I'm going to set the equation equal to 0. So instead of y is greater than, I'm going to put 0 equals x plus 3 squared minus 9. My first step is to add 9 to both sides. So I end up with 9 equals x plus 3 squared. I square root both sides. On the right, my square and my square root cancels out. The square root of 9 is 3, so I get 3 equals x plus 3. But don't forget the square root of 9 is also negative 3. So I also have negative 3 equals x plus 3. Okay, guys, so I should set up two separate equations. From here, to solve, I subtract 3 from both sides. I do the opposite operation. So on the right, my 3's cancel out, and my first 0 is x equals 0. For my second equation, I subtract 3 from both sides. On the right, they cancel out, and my second 0 is x equals negative 6. Okay, so now I have my vertex at negative 3, negative 9, and I have my two zeros at x equals 0, x equals negative 6. Now let's go to the next slide where we're going to graph this. All right, so here's our graph. Okay, guys, notice here is the vertex form that we came up with. Here is our vertex, and here are the two zeros that we did on the last slide. So let's go ahead and graph that. My vertex at negative 3, negative 9 would be down here. Remember, we always go left or right first. So we're going to go left 3 and then down 9. Okay? Now let's graph my zeros. Remember, my zeros is where the parabola crosses the x-axis. So if it crosses at 0, I cross right here at 0. So that would be x equals 0. If it crosses at negative 6, I just put my point there, x equals negative 6. And let me label my vertex here at negative 3, negative 9. From here, before you connect the parabola, look at step 5. If it's less than or equal to or greater than or equal to, it's a solid line. If it's less than or greater than, it's a dotted line. So go back to the original equation. If it's greater than, that means that we are going to be graphing a dotted line. Okay? So I'm going to dot my line all the way through. All right? And let me continue here on the other side of the parabola. But notice I'm making a dotted line. Now we're going to shade. My last step, step 6. If it's greater than or equal to, I'm going to shade up. If it's less than or equal to, I'm going to shade down. And remember, I always start at the vertex. So if my inequality symbol is greater than, that means that I'm going to shade up. So I go to my vertex. Here's my vertex at negative 3, negative 9. And from my vertex, I shade up. So I would shade everything here inside of that parabola. So there is my final answer. Okay, guys, your answer is a graph. Your answer is not going to be x equals something. All right? So there is our answer with our graph. That's it for our PowerPoint. Your homework is worksheet 10-6, so make sure you go into Google Classroom to find that and submit it. This is what it will look like. Notice the first section here, the warm-up, just has you tell me whether each ordered pair satisfies the inequality. Remember, we are going to be plugging in, and you're just going to tell me if it's true or false. And then here for the bottom half of your homework, you have 4 problems where you're graphing on a number line, and then 2 where you're graphing on a coordinate grid. Okay, so just go through, again, leave any questions that you have in the comment section of Google Classroom. Okay, and thank you guys so much for joining me for that lesson, and I will see you for our test review next time.